LCD control using Arduinos on Tinkercad and the LiquidCrystal Library. In this part, we will be programming the LCD or be programming the Arduino to control the LCD. But before we do that, we want to add a switch to the circuit. So we search for tilt switch. You can use either of the switches, but I want to use the tilt switch with the 4-pin. So drag and drop it onto the breadboard. So first thing I want to do is connect one side of the switch to the 5V source. So because it's 5V, I want to change the color of the line to red. Then when it's not closed, we want to add a resistor of about 10 kilo ohms, which is strong enough resistor to take care of any leakage current. So we add 10 kilo ohms, 10 kilo ohm resistor. So we've got 5V connection. If the switch is not closed, goes through 10 kilo ohm and connecting it to ground. Now when the switch is closed, we want to connect between pin and a digital input to the Arduino. So let's use pin 6 in this particular case. We connect pin 6 to the switch. What we want to do is change the color to something right turquoise. That works. So what's happening is when it's not closed, you've got you got the switch opened, but you've got the 10 kilo ohm resistor on there trying to take care of any current going through the switch. Now, to also when you press when the switch is closed or you press the switch, if it's a push button, in this case we've got a tilt switch. What happens is because current prefers to flow through the least resistant path, the 5V will be connected through the wire, so it bypass the 10 kilo ohms, so through the wire to the input pin 6. So that completes the circuit diagram. We want to start programming our Arduino. So we go to the code. We don't want block programming, we want test programming. Say yes. Then it comes up with a basic code for you. So let's get rid of the digital write for pin 13. And then we have our setup and then loop functions. Make use of the LiquidCrystal Library. You press the library icon and we select include the LiquidCrystal Library. So first of all, what we want to do is to find out more about the library. So to do that, you just press this arrow button, then it should take you to the reference page. So on there, you've got the LiquidCrystal Library, you've got some examples on how to use it, and you've got the frequently used functions. So we'll be using these functions in a few seconds. First of all, what we want to do is include the library. So as soon as you press it, you've got the LiquidCrystal Library being included for you. So if we go to the reference for the LiquidCrystal Library, you notice we've got a constructor to initialize the pins, which is the LiquidCrystal. So we select LiquidCrystal, and in the constructor, you notice you've got 4 different options where we can connect the register select to the first pin and make use of the enable pin, and then we have the 4-bit mode upper enable. Or you can make use of the read write if you'll be reading and writing to the LCD. That's the way you insert the read write in the second one. And then also you can make use of the 8-bit mode, similar ones, with one without the read write and one with read write. We didn't make use of read write, so we'll be going for this option. So we've got a register select, and then we've got the enable pin, and then D0 to D7. So if we go back to a circuit, we write constructor, which is LiquidCrystal, liquid crystal. And we can give it a name, LCD, and in that data type we have, in our case, we've got pin 12 highlighted being connected to the register select. So the register select is pin 12, comma, and then comes the enable pin, and the enable pin is connected to pin 11. Pin 11 for the enable pin. Then we've got D4 to D7. Our D4 is connected to pin 5 and D7 is connected to pin 2. So we got 5 down to 2. So we've got 5, comma, 4, 3, 2. Now we need a few variables. So we need some constant variables to control the LCDs. Let's declare our global variable. So what we intend to do is have a switch pin. So we don't expect the pin to change. So we use the const keyword and say int, and we will call it switch pin. And our switch is connected to pin 6. So switch pin gets connected to pin 6. Then what we want to do is check the previous state and the current state of the switch. So in order to do that, we need to declare state. So let's call it switch state. Initialize that to 0. Statement. Then we need the previous state, previous switch state, that also initialized to 0, and we can have maybe reply. So with our reply, what we want to create for this particular circuit is just a digital hourglass. Digital hourglass randomly predicts if someone presses a switch, it will just basically give a message on the LCD, which is form of prediction. So the reply on here will be used later on for that. So within our setup, we want to initialize the input pin, which is the switch. So let's initialize the switch to an input. So pin mode, switch pin as input. By default, the pins are configured as output. So pins going to the data bits of the LCD, which is the data pins, and also the register select enable pins. Other pins going to the LCD by default will get become output. So now in the for loop, we want to initialize the LCD. So what we can do is let's do some configurations for the LCD before even we look into the loop. We move to the loop function. Go back to the liquid crystal display function. So we have the begin function to initialize the LCD. So we've got begin, and in the begin we need to set the column and the row that we want to set it to, and also we have the print. So basically we begin by setting the cursor position, then we print to a message to the screen. So we can use the print to print a message to the screen where it's a print, then data, and more we have the set cursor, which sets the position of the cursor after we print. make use of the set cursor, we have column and then the row similar to the begin, and then we can make use of another print. So in the loop, let's set the configurations of the LCD. So let's set it up by saying LCD dot begin, and first of all we want to set it up to position 16. So you've got 0 to 15 and 16 to 2 by on the so one first line and then the second line. So let's set it up. We go for 16 as the position, and the row we go for row 2, and we want to send a message, so we say print. Message do we want to print on the LCD? Let's say we print ask a question. Then we want to move to the next line and say LCD dot set cursor to the next position, which is position 0. So we have 15, the 16, then we want to stay on position 0, and so we set the position of the cursor, and then we can send another message, the second line, that says I know it all. So ask a question, I know it all. So if a person asks a question by tilting the switch, we want to make a decision or randomly guess from a set of possible answers or preset answers. So what we want to do is first of all read the switch. So let's say digital read the state of the switch, and the switch pin is switch pin. Now when we read the switch pin, what we want to do is to assign it to the state of the switch. Basically we read the switch, just assign to the state, and after we assign it to the state of the switch, we want to make some decisions based on it. So we will say if the current state, which is the switch state, is not the same as the previous state, so if it's not equal to the previous state, so previous switch state, if they are different, then what we want to do is to do something. So basically we go in. So if the switch state or the current state is not equal to the previous state, basically what we want to do is first of all check if the switch is low. So let's see switch state. So if switch state is low or 0, then what we want to do is randomly select between 0 and 8 or 1 and 8. So if we go to the Arduino reference page, we see how to generate random numbers. You can make use of the random seed. A very good approach is to connect the random seed to pin 0, which generates random noise, and then you use that random noise to set the Arduino. So you've got random seed on there, so hence you can read analog pin 0 as a random seed. You can copy that across into our setup. So make use of the noise on the receive signal of the Arduino. Then we can make use of the random. So if you go in there, random, have a look, see random, we can make use of a minimum and a maximum. So we are going to choose random. We're just going to use a maximum because we've got only 7 bits, so between 1 and 8. back here. Then we call random number between 1 and 8. So say our reply, which is the results, should be equal to random ransom 8. So generating the random number. Now what we want to do is to perform check the value of the reply, and depending on the value we can make a decision or we can print a message. So if we go back to the Arduino reference, so if we look at Arduino reference, on there we have switch. We've got a switch case statement, which is quite similar to the if-else statement. So we do a switch, a test on a variable, and then depending on the value of the variable, so in case 1, if we execute something, then if that is satisfied, we break out of the loop or out of the condition. If you do want to watch more about how the break and continue functions work, there's a separate video. You can put the link in the description of this video. So default means after we've gone through all the cases or the test cases, if we are not considering any case, or if there's a case that a state of variable that exists that we've not catered for in the case, default will run and execute it, and afterwards go through a break. So we generate the reply and we are going to use switch case, but before we do that, let's clear the LCD to make sure and do some small setup on the LCD. So LCD, the clear function, and this function is available in the LCD library functions. So LCD clear, message that we put up, and also let's set the cursor to position 0, 0. Set cursor to 0, 0, and LCD, we want to print a message to LCD. So LCD print, and we can send a message, say my answer is, and we set the LCD to the next line so we can print our message there. So let's set the cursor to the next line. So set it to the next line. So if you want reference, quick reference, we go to set cursor, and we notice that in set cursor you've got a column and the row. So now back to our switch where we'll be making the actual decision on the reply. So we say switch reply, switch on reply, then we have open close. So we say random number between 0 and 8. So maximum 0 and 7. So maximum we can have is 7. So between 0 and 7. So random number is switch case. If the value of reply is 0, what should we do? Basically LCD dot print. You just say definitely a yes, go for it. Or simply say definitely yes. Then if the case was 0, we finish, we break out of the switch. Otherwise, we're in case 1, we print LCD print, and we say probably. Then we break out of the switch, case 2, break semicolon, case 2, we can say LCD print, and we can just say sure, why not? And center in the statement and break. Then we can go for case 3, case 3, open, LCD.print, and we can say looks good, and it, then we break, and case 4, we say LCD.print, and we can say not sure, break again, say case 5, and LCD.print, we just say try again, column, then break, case 6, and go LCD.print, say I doubt that, semicolon, then break, and the final case, case 7. Because we've covered all the cases, we don't need to put a default. So case 7, say .print, you just say never. And break. So we have our if, yep, and almost all of them being closed at the right time. We can try our simulation, see if there are any errors in the code. There is an error in the code. It says class LiquidCrystal has no identifier called setCursor. So if we go to the line 31, just on top, expecting an error that we missed it, which was setCursor. So we run it again, see if there are any errors in the code, and luckily there are. So we start the simulation and we expect a few errors, but it's very good. It will help us improve the debugging skills. Okay, so start the simulation. We notice first of all nothing shows on the screen. So what we want to find out is that are we using the right contrast? So we adjust the variable resistor, and voila, within a certain small range we get some data being shown on the LCD. It is upside down, but we'll fix it later on. So we try to switch to see if something is happening. We tilt the switch, nothing is happening. Move it down, tilt the switch, same message all the time. And also we notice that the LCD is flickering. You see that flickering message there. So what is happening is that at the moment we have put our first message, which is ask the question and annoy it all. So each time it loops, it's going to come back to refresh the same message. That's not very convenient. What we want to do is to move it to the setup so it runs only once. So that message appears only once. Say ask the question before in the loop function we get to ask the question. Now we start the simulation again and we notice that even though we changed it, now the flickering has stopped, but even though we've changed it, the results is still the same. The switch does not work. So what is happening? First of all, we can view the value of the switch to see what is happening. So let's add the serial monitor. So initialize the serial monitor, which is serial.begin, and that will be 9600. You can use other baud rates if you want, but we choose 9600. And at the bottom, just before the end of the loop, the end of loop function, just before the end of the loop, we want to print serial.print the value of the switch state. So let's print the switch state and see what is happening. So if we have another look, run it, we notice that the switch state remains the same, 111 throughout. So let's actually say serial print and line. So what we know so far is that the switch is actually connected to a high voltage throughout. So let's run it again. You notice it goes 11111, change the state of the switch, nothing is happening. Move it back down, nothing is happening, because the switch is tied to a high voltage signal, which is a high on here. So the actual mistake lies here because both the input and the output of the switch have been connected to the 5 volt source, which is not ideal. To rectify it, we can move this line up, stop the simulation, move this line up to make it a lot cleaner. Then we can move the resistor so that we connect the resistor to the ground properly instead. So now when we start the simulation and we change the state, we should expect 0 on the output. So we change the state, we notice it goes 0, 0, 0, and then we can switch it back. So tilt the switch back. So now we're getting the right state, but we are still not getting the data on there. So if we go back to the code, we notice that we are actually reading the switch and assigning it to switch state. However, in the if statement, or the main if statement, where we double check the value of the switch, if it is not equal to previous state, we never update previous state anywhere in this particular code. So once we change the switch state, it will always be the same as previous state will always be the same. In this case, previous state will always be 0, and the switch state will always be what we read. So what we can do is to update the value. So switch state, we assign switch state to be equal to the previous state to be equal to the switch state upon completion of that line. So how we work that out, we've got a switch state and we assign it to, which is the current state, to the previous switch state. If we've got everything spelled out correctly, we expect it to run without errors. which is as expected. So we change the state. Now we notice that the result is displaying, and then change the state, we're getting different results this time. So what we want to do is to rotate the whole screen, and to rotate it you can either use this icon there, or you can use you can just select the device and press R as always. So I'm going to start off by selecting various components individually after I stop the simulation to rotate the screen. For multiple selection, you hold down the Shift key and then you select the component you want to rotate. Shift key down, select each component, press R to rotate. So the same circuit, nothing has changed, just rotate it, and we can now run the simulation. So start simulation, then it says ask the question, I know it all. Select the switch, switch on, it says my answer is not sure, down, tilt again, same, tilt, says never, it's never, not sure, I doubt that. Look good. Okay, looks good. Enjoy programming.